Hey guys, it's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to use the formula for the sum of a finite arithmetic series. So, we're going to take you through some notes first, and what we've been working with so far have been arithmetic sequences. And so, we've got a sequence like the one at the top of this box. We've got 2, 4, 6, 8, 10. Now, the corresponding arithmetic series is going to be 2 plus 4 plus 6 plus 8 plus 10. And we could actually find the sum. But for now, we're actually just going to take a look at how a series looks. And we've got a second sequence. We've got -8, -3, 2, 7. The series that goes along with that sequence is -8 plus -3 plus 2 plus 7. We could also have things like the sum of the first 100 natural numbers. Natural numbers are the same thing as countable numbers starting at 1. So you've got something like 1 plus 2 plus 3 plus everything in between up until 100. And we could also have something like the sum of the first 5 perfect cubes, which is 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. Now the sum of a sequence of numbers is called a series. And there's two types of series. It can be a finite series or an infinite series. Now an example of a finite series is one that we have right above. You could have something like 2 plus 4 plus 6 plus 8 plus 10. An infinite series, well, that's something that goes on forever. So that could be something like 1 plus 2 plus 3 plus 4 plus going on. Now it is possible for us to calculate the sum of all finite series, but not necessarily is the case for infinite series. We can actually calculate the sum for only some of them. Before we begin, we have to introduce some new notation. Now before, we used things like a sub n and g sub n. Those represented sequences. To represent a series, we're actually going to use s sub n, where s means we're looking for a series or we're looking for a sum, and n is going to be the first n number of terms. So, for example 1, we have to calculate the sum of the following series and write the appropriate subscript for the sum. Now we've got something like 5 plus 9 plus 13 plus 17, which we can add up. There's only 4 numbers. And that's actually going to be 44. Using new notation, however, we can say that the sum of the first 4 terms is 44. For part B, we're actually given a sequence of 1, 11, 21, 31, 41, 51, 61, 71, and we're asked to find s sub 4, or the sum of the first 4 terms in that sequence. And the first 4 terms are going to be 1, 11, 21, and 31. So the sum of those numbers is 64. And that's it.